I would just like to say hello to everyone. Good morning, good afternoon, good evening. All of us that are greeting you today on this presentation are coming from all over the globe, just as you are. My name is Beth Filer-Williams, and I'm on the standing committee of ENSULIB section. I'm a user experience research librarian at Oregon State University Libraries. So I want to welcome you to this webinar. It's provided by ENSULIB, IFLA's Environmental Sustainability and Libraries section. We're really proud to present our 5th webinar on neighborhood science working locally to confront global challenges. We're going to learn today how libraries are working at the forefront of citizen science, the connection between NASA science, climate change science, citizen science observations, and mosquito-borne disease, how the International GLOBE Mission Mosquito Citizen Science Campaign is providing a common language and approach for meeting the global challenge to ensure good health from all mosquito-borne diseases, and examples of resources and partnerships that public, academic, and research libraries can leverage. Before we begin, I want to make a comment on privacy and administration. This webinar is being recorded. The video will be posted on YouTube and posted on our ENSULIB website as well. I'm going to put the link in the chat. Microphones have been muted for this event. If you have questions, we would recommend putting them in the Q&A. And if you have questions regarding privacy, you can send them to the email address on the screen, professionalsupport@IFLA. Next, I am pleased to invite Petra Hauk, the secretary of the ENSULIB section and visiting teacher at the Berlin School for Library and Information Science in Germany, to give the welcome introduction.
Thank you, Beth. Hello, everyone from my home city, Berlin in Germany. I greet you cordially in the name of ENSULIB, IFLA's Environment, Sustainability and Libraries section. We are very happy to see that there are so many colleagues from around the world interested in ENSULIB's 5th webinar. As you might know, ENSULIB started its career long ago as a very small special interest group, but after many years of hard work and with a growing interest in sustainability issues, ENSULIB received the status of an IFLA section only in the beginning of 2021. Now we have a very smart standing committee of 20 members from all over the world, chaired by Harisaha Virta from Finland and with Priscilla Pan from Macau as our information coordinator. The section started its work in August 2021 and could already present an impressive range of projects: the newsletter, the webinar series, the 7th IFLA Green Library Award competition, to name but a few. Now, ENSULIB is proud to have been awarded with the Dynamic Unit at Impact Award at the IFLA conference in Dublin in 2022. And I invite you cordially to visit our website for more detailed information. I wish to thank especially Vivian Bird from Los Angeles, now Macau, ENSULIB's newly elected standing committee member, the initiator and speaker of ENSULIB's 5th webinar, and also our standing committee member, Beth Filer-Williams, joining us today as facilitator of the webinar. I also thank Rusty Lowe and Theresa Schwerin, representing the Institute for Global Environmental Strategies, who accepted our invitation to present their paper on neighborhood science working locally to confront global challenges, together with Vivian Bird. And now I'm handing over back to Beth. Thank you.
Right, thank you so much. I'm going to introduce the speakers and then I'm going to turn it over to them for the reason that you're here today. The first speaker we have is Vivian Bird, Librarian 3 at Los Angeles Public Library. With 18 years of experience in the areas of public library programming and community engagement and outreach, she leads LAPL Full Steam Ahead Initiative and Neighborhood Science Initiatives. Vivian currently serves as a library advisor for NASA's Eclipse Ambassador Off the Paths project. And then we will have Rusty Lowe, PhD. She is a climate scientist and educator at the Institute for Global Environmental Strategies, who works at the forefront of citizen science and its application for mosquito-borne diseases, such as Zika, West Nile virus, and Dengue. She is the science lead for the GLOBE Mosquito Habitat Mapper and GLOBE Mission Mosquito. Using a free mobile app, citizen scientists of all ages and community health professionals can work together with NASA scientists to reduce the outbreak of mosquito-borne diseases in their community. And then last, but of course not least, is Teresa Sherwin. She is the IGES Vice President for Educational Programs. She leads the NASA Earth Science Educational Collaborative, which is a partnership between IGES and the Earth Sciences at 3 NASA centers: Goddard Space Flight Center, the Jet Propulsion Laboratory, and Langley Research Center. The NASA Earth Science Education Collaborative provides opportunities for lifelong learners to participate in NASA Earth Science. Ms. Sherwin has an MLIS, Master's in Library Science, Information Science. She fosters innovative collaborations to bring Earth observations to formal and informal education, and is working with libraries to engage their communities in citizen science. So I'm going to turn it over to the speakers and looking forward to hearing them speak.
Thank you, Beth, for the introduction, and thank you, ENSULIB, for the opportunity to share with everyone about neighborhood science. And let me go ahead and start my slide deck here. 1 second. All right. So can you all see my slide deck? Yes?
Yes.
Okay, awesome. All right, so I will go ahead and start the presentation, and I will be sharing some of the examples from the LA Public Library's neighborhood science programs first, and then we will have our special speakers speak. So I'm going to start my slide deck with this quote because it's essentially what neighborhood science is about. It's all about learning and begin caring through active physical participation and involvement in real science for your community. Neighborhood science is more commonly known as citizen science, community science, C*science, or even street science. It's about public participation and collaboration with real scientists in real scientific research. It's about turning our curiosity and concerns into impact. At Los Angeles Public Library, we decided to name our program Neighborhood Science to avoid the confusion of that only U.S. citizens are allowed to participate. We also focus on neighborhood science aspect of involvement in these research projects and local impact that our participants can relate and connect to. Los Angeles Public Library began piloting the idea of turning our branches into citizen or neighborhood science hub in 2018. The mission of the program is to augment LA Public Library's existing hands-on STEM programs with community-connected, real-world, and fun experiential learning to foster conservation and environmentally minded STEM interests in the participants of all ages and all backgrounds. So you may ask, why doing neighborhood science? As we continue to pilot programs, we learned that neighborhood science help address and raise awareness of many pressing real-world challenges that affects these local communities, especially in the underserved populations. Participants are not only learning about science behind environmental or sustainability issues, but through these hands-on data collection, classification, or analyzing activities, using something as simple as a smart device with internet, they may see it, experience it, or possibly notice it for the very first time that many of these so-called global issues are not just an abstract concept or a problem that's far, far away, but it is something really happening very close to home. Neighborhood science also strengthen the bond between participants and their communities. The shared insight and knowledge gained through the data collection process could also enhance neighborhood cohesion, develop empathy, and encourage environmental stewardship as they now know that their health and well-being are affected by these issues. In addition, neighborhood science programs is a great way to promote and educate the public and support the achievement of the United Nations SDGs. For example, the neighborhood science program at Los Angeles Public Library could support up to 10 of the 17 UN SDGs. The data collected through these neighborhood science projects could be used to help monitor roughly 33% of United Nations SDGs 247 indicators. So how do you offer neighborhood science in libraries? When I'm talking about libraries, I don't mean just public library or community libraries. It can literally be done in any type of libraries. It can be special libraries, academic libraries, school libraries, and community libraries. Here is a quick and very wordy list of how the step that Los Angeles Public Library took to create and develop neighborhood science programs. What we did is first, we took the time to identify the key issues and concerns in the communities that we serve. We did so by survey or casually chat with the patrons that walk in through the doors, and we also involved the librarians and library staff who's always at the forefront interacting with our patrons. We also do a bit of research and learn about the sustainability and key environmental issues that either the country, the state, or the city is currently focusing on. For example, in the United States, right now, Biden-Harris administration's America the Beautiful plan calls for locally led, voluntary, nationwide effort to conserve, connect, and restore 30% of our lands and waters by 2030 for the sake of the economy, health, and well-being. This led to the launch of California 30 by 30 initiative, and as a result, every participating city in the state also developed their own 30 by 30 goals. Then we reach out to the city's sustainability office, the neighborhood council office, the local or grassroots environmental justice or climate groups to find out what their current projects and focus and campaigns are. Then we request to attend the meetings to learn more about their projects and see how our library can fit into the pictures to support their effort and get more buy-ins from all different stakeholders. Next, we start doing some research, more research, and identify citizen or neighborhood science research projects that's related to identified issues for the communities. And we want to make sure that these so-called neighborhood or citizen science projects would allow our community members to participate hands-on. We did so by doing search on 4 main platforms. That's NASA Citizen Science page, NASA Globe page, SciStarter platform, and Zooniverse. After we have those identified, we move forward with identifying and form partnership with local groups and identify and form partnership with local groups and then all the way to citizen science project developers. The reason we did so is we found out these partnerships are extremely valuable. Oftentimes they could provide you with resources, supports, and networking, and possibly funding opportunities. They could also help provide contents or subject matter experts for your library programs, outreach events, or library staff training. Most importantly, they can help you amplify your effort by spreading the word about your programs, your events through their own channel. Here are some of the partners we have or continue working with for the neighborhood science program. And you can see, I know there's tons of logos here, but our collaborators range from local grassroots groups all the way to federal agencies. Next, we create and promote in-library and online programs and outreach events. When we talk about promoting or creating programs, we typically think about the type of programs and age groups. That would be talks, hands-on workshops, scavenger hunt, bio blitz, nature walk, book clubs, or meetup groups. We also think about the content of the program, how we can tie them into the environmental days, some special campaigns, and also how we can get more buy-ins from participants to contribute data for greater good. We also think about spark interest or sustaining interest in library users. To do so, we go for what we call semi-passive approach by creating and offering what we call the do-it-yourself neighborhood science kits for each environmental issues that affect the communities in LA City. And we connect it to with at least one citizen science project. Anyone with Los Angeles Public Library card can check out these kits to learn about the topic and conduct observation in or around their homes or neighborhoods at their own pace. All of these kits are currently available at 29 of our neighborhood science branches, and they're also aligned to the science standards adopted by the local school district. That way, the teacher can also use these kits in the classroom. We currently have 6 kits available for circulation. They're clouds observation with NASA GLOBE, water quality monitoring, air quality monitoring, light pollution monitoring, and exploring biodiversity, mosquito habitat mapping with GLOBE Observer. And the last one we're currently working on is to educate the public about urban heat island effect and the importance of tree height measuring and land cover monitoring. And all of these kits are currently only available in English as we are still modifying some of the contents, but our goal is to eventually translate all these kits, the content, everything about them, including our website, into multiple languages. That's Spanish, Japanese, Mandarin Chinese, and Korean, and so on and so forth. And I also want to mention that keep in mind that citizen science or neighborhood science activities don't usually require anything but a mobile phone with internet connectivity. But if you're able to secure a budget to create kits, it will really enhance participants' experience and reinforce the development of citizen scientists or neighborhood scientists' identity. Since most of the public still seeing scientists as people using sophisticated tools to conduct studies or research, especially among younger participants or audience. Our neighborhood science librarians also create fun and easy to follow hands-on STEM video tutorials to explain the science behind some of the environmental concerns, such as ocean acidification, sea level rising, indestructible plastic, and others. Next, I want to share with you an example of our successful NASI or neighborhood science campaign that we have initiated that has really benefited not only the city, but the residents in many different ways. In 2021, to introduce the residents of Los Angeles City to citizen science and really raise awareness of urban biodiversity and habitat protection, we partner with our Department of Sanitation and Environment to launch the city's its very own first BioBlitz challenge to involve the local residents in the collection and mapping of wildlife and plants using popular citizen science app called iNaturalist. To ensure the inclusivity of the program, we also translate material into Spanish and will translate into other languages next year and beyond. The reason I said beyond is because our first BioBlitz in 2021 was so successful that it has now been adopted as a citywide annual event. And just in case if you're not familiar with the term BioBlitz, a BioBlitz is an event that focuses on finding and identifying as many species as possible in a specific area over a short period of time. At a BioBlitz, scientists, families, students, and teachers and community members can work together to get a snapshot of an area's biodiversity. These events can happen in almost any geography: urban, rural, suburban, and in areas as small as a backyard to as large as a country. As we crowdsource the collection of biodiversity data to support the City of LA's biodiversity research, our participants were out there exploring and connecting with their neighborhoods and observing wild plants and animals. The community participants were learning about what it means by the city of Los Angeles being in one of the 36 global biodiversity hotspots, the importance of mapping what is called the indicator species, helping us discovering invasive species that can be hazardous to the community, especially related to wildfires, and also helping us reducing what we call the observation cold spots by photographing and sharing their observation in areas that has zero or very, very few biodiversity data collected. We notice is that participants quickly associate the frequency of and counts of roadkills in certain locations in their communities to biodiversity loss and contribute that to research as a pointer for conservation needs. For the city of Los Angeles, this large amount of data that have been collected through the challenge really helped the research team to better understand the distribution of different species of plants and animals, and also the quality of the habitats across the city, especially in what we call the observation cold spots. It also helped our research team quickly identify the critical locations for habitat conservation and check the progress of existing conservation efforts. Here, I want to share some of the findings that that was generated through our 2-year worth of these BioBlitz challenges. So last year we did an 8-week challenge, and this year we did a 4-week challenge. We collected over 23,000 observations and these two challenges combined, we have successfully found, mapped, and identified 31 of the 38 indicator species in the city. In the first year, we were able to reduce the observation cold spot by 16%. In the second year, we reduced the observation cold spot by another 6.7%. In both years, we found that red-tailed hawk and the great blue heron are both most observed indicator species. So what that means to us is that the city actually provides a good quality habitat for these two animals. In addition, the biodiversity team was able to complete one of the city's most comprehensive biodiversity index baseline report. With that, we now have a very clear understanding and updated information about the city's biodiversity distribution and the status of the conservation effort. And all of this knowledge is vital to help the city achieve its California or the city's own 30 by 30 goals. Now you have seen how neighborhood science can raise awareness, enhance community cohesion and engagement, and promote an active and scientifically literate citizenry ready to address local sustainability issues. Next, Dr. Rusty Lowe will share with you all how local neighborhood science participation play an important role in helping the NASA researchers and the world to gain a better understanding on the impact of climate change and sustainability issues.
Thank you. And I was going to say, it's just such an exciting thing to see all the things that you have been able to accomplish in LA. And I'm glad that they have spent a little bit of time not looking for the charismatic animals and plants and BioBlitz, but also looking for some of the ones that cause real health problems. So thank you. I'm Rusty Lowe, and I am the senior scientist at IGAS, and I also work as the science lead for Globe Observer Mosquito Habitat Mapper. And so I'm just going to talk a little bit today about why we're doing what we're doing, why it might be exciting for you to do something like this, and give you just a little bit of background, science background to go with this talk. And Vivian, you're going to press the slides, correct?
Yes, I am.
Thank you.
So let me know when you want me to advance. Just say next slide.
Next slide.
Awesome.
So in the chat, we have 3 questions for you to consider before we start, and just put your answers in the chat. So if you are in an area where, in the poll, thank you, if you're in an area that has seasonality, does it seem that the mosquitoes are arriving earlier and leaving later than you remember as a child? And if you're in a tropical region that is wet all the time, that might not be the case. If you have wet and dry seasons, it would be the case. So does it seem like this mosquito season is longer? So just say yes or no, and then we'll move on to the second question.
All right, so I'm going to end the poll here.
Okay, the second question is mosquito bites. Most of us have suffered mosquito bites our whole lives. And does it seem to you that the mosquito bites are maybe more painful than they used to be as a child? You know, it's hard to remember, but wow, do they bother me more than they used to? So that's another question. Yes or no?
I have to show the result because I thought it was interesting.
Oh, okay. Great. Thank you so much. About the same. Excellent. Thank you.
Mm-hmm.
And then the last question is, who is responsible for mosquito control in your community? So, you know, who takes the lead in finding mosquitoes, eliminating mosquitoes? You know, who's responsible for that in your community? And just go ahead and put that answer in the chat. And when we're done, we'll move to the next slide. Okay, so this is what we're going to talk about today. What I'm going to be doing is talking a little bit about mosquitoes and why NASA, who sees things from space, is interested in things as small as mosquitoes, which you can't see from space. The next thing is I'm going to talk about the citizen science program we have working with Globe Observer, which is a NASA citizen science program for Earth science. And then I'll talk just a little bit about some of the research that is being promoted by the data that's collected by citizen scientists. And then we're going to go on and talk a little bit about how to get the data once we collect it, and how you can actually use some of the resources that we have developed as part of this program to develop your own programming using our tools and our educational resources. Actually, I never studied entomology as a student. I actually studied climate science, but I was always interested in how do we get people to talk about climate science, because climate is something that changes. It's kind of a statistical concept, so we can't experience it ourselves. We experience, on a day-to-day basis. We might experience the increased extreme earth events, like hurricanes and tornadoes and things like that, floods and fires, but we don't really experience climate per se, the kind of change that we're expecting to see. And, in trying to think about how to communicate climate, I thought, what's a climate thing that we have everywhere that everybody can relate to, everybody notices all the time? And then I thought, aha, mosquitoes. People don't like them, but they're ubiquitous. And so I thought that mosquitoes might be a really great way to talk about our changing climate. And it's true, because our mosquito seasons are starting earlier and they're ending later. And in the US, we talk about people, when people need a ride on the side of the road, we call it hitchhiking. You stick your thumb out, and if you run out of gas, someone will pick you up and take you to the gas station. And this is kind of what mosquitoes do. They hitchhike from one continent to another continent. And so we're having these species expand from their endemic place where they grew up, where they are found, and they become invasive species in new areas. And because this is happening, the other thing is, besides having a longer mosquito season, we also have mosquitoes that, as the climate is warming, they are expanding poleward. So mosquitoes that were found primarily only in the tropics are now found in the subtropics. And so these are the kinds of changes that we're seeing. And so to address these issues, the team that I'm working on developed the GLOBE Mosquito Habitat Mapper, and it is a mobile app device that you can put on a smartphone and use this to monitor mosquitoes in your region. Thanks. Next one. And I'm sorry that this is very US centric, but just to give you an idea of in the US, we have a lot of change in that in the climate over time. And we see that in mosquitoes. So this is the answer to poll question 1. Have you actually seen a longer season? Well, in some places, for instance, in Hawaii, the answer is no, we haven't. It's the same season we've always had. But if you go to Reno, Nevada, we have actually 52 days. So the mosquito season is a month and a half longer than it was. And so you can see that most places in the US, the mosquito season is about 2 weeks longer than it was than when I was a child. And that is actually pretty significant from a health point of view and from a biodiversity point of view. Okay, so that is poll question 1. Poll question 2. So here are 2 of those bad hitchhikers, Aedes aegypti, which is also called the yellow fever mosquito, and Aedes albopictus, which is called the Asian tiger mosquito. And the Aedes aegypti mosquito was found principally first in Africa. You can now see that it is now found all over the globe. And the Aedes albopictus mosquito originated in Southeast Asia. It is also found all over the globe. So these are 2 of those hitchhiking species that I'm talking about. Both of them are very competent vectors for disease. So this really makes us nervous, and we are fighting the diseases that they are bringing to our communities. But this is the answer to poll question number 2. If you have experienced, and I'm glad to see most people haven't, this is a good thing. But if you have been experiencing bites that hurt more, surprisingly, the Aedes aegypti mosquito is a very painful biter. And so if you grew up in a place where there was not an Aedes aegypti or an Aedes albopictus mosquito, and now there is, you might find that the bites are bothering you more than it did. Okay, so the next one, please. And the question people always ask Teresa and I is, can NASA see mosquitoes from space? And I said already, the answer is no, they're just way too small to see from a satellite. But what those satellites in space do is they are monitoring the environmental conditions on the Earth. And those conditions then can be examined to see whether or not they are favorable for the development of mosquito populations and disease outbreaks. So while NASA can't see mosquitoes from space, they can see the conditions that might cause mosquito populations to grow, explode, and create epidemic disease. And so NASA science is very tied into those scientists who are modelers, who are telling us it's going to be a bad West Nile season. Watch out for Zika, and so on. Okay, next one. And so once again, here's the thing, they can find, NASA can find those conditions, but are mosquitoes actually there? And that's where our citizen scientists come in. You make the connection between satellite data and mosquitoes. And in our app, we have 4 different tools. I know that Vivian mentioned there's a tree tool that she's working with in LA. We have the mosquito habitat mapper and the land cover tool. And the mosquito habitat mapper lets you identify where you find breeding sites and what kind of mosquitoes you find. And the land cover tool lets us know where, what kind of environment did you find those mosquitoes? And so both of those are very important, and we ask you to use those apps in order to help us help scientists protect us from vector-borne disease. Next one. We use these 2 tools to determine where we find the mosquitoes, and it helps us pair our mosquito observations with environmental data. So you may know that mosquitoes are typically found in wet areas. So people think of places like ditches, ponds, swamps and wetlands, reservoirs and lakes as places where you might find bad mosquito outbreaks. But what we also find is these are one kind of mosquito. These are called the floodwater mosquitoes. And there is another whole division of mosquitoes called container mosquitoes. And these are the ones that tend to be typically really problematic in our cities and in our in human habitation areas. So it's pretty easy to use a mosquito habitat mapper. I'm just doing this, so maybe you'll get excited and you'll want to do this with your contingency. But the app has 5 steps. You open up the app and it says, here you are. This is what time it is. This is where you are. You press a little button and try to get that estimated accuracy down to about 10 meters. And there you go. You're able to say where you have found the mosquito habitat. And then we have a pictorial key here where you say, what's the source of the water? So maybe it is a container, maybe it's a trap that you have built with your library patrons so they can monitor and look at mosquito growth. Containers like spare tires are really dangerous places because mosquitoes love tires. And that's in fact how they moved from Southeast Asia all over the world, was in the spare tire trade, because they live in the water that pools in the tires. So you identify the breeding site you find, and then they ask you, are you interested in counting the larvae and saying what you find? And you can say yes, or you can say no. You can stop at any step. So it's really good with kids. You can do a mosquito walk, find those potential habitats. But if you do find mosquitoes, you can actually sample them, look at them under a little microscope we have. It's a little clip-on microscope. It costs about $5. You can put that on your phone, and then you can identify, using our pictorial key, whether or not you have one of the 3 most dangerous medically important species identified. And then last, we ask you to take that 3rd step, and that's the really important step. We asked you, like, who's responsible for monitoring mosquitoes in your area, and you may have a mosquito control agency. Most of the US does not, most of the world does not. So it really does rely on you to do this work. And this app will help you to stimulate interest in your community to do this. To summarize, we have 3 strategies to protect our communities from vector-borne disease. Most of our vector-borne diseases do not yet have vaccines to protect us, but so we have to do 3 things. Surveillance, find those mosquito breeding sites and decommission them and take them out of use. That means, you know, clean out standing water that you might find in puddles. Mitigation, get rid of those spare tires that are laying around so they don't become mosquito sites, and then education. And the Mosquito Habitat Mapper does all 3. So it's a very powerful tool for your community to improve health. I just wanted to say, this is one of our patrons that we have worked with. His name is Herb Koreyashi, and I taught a class at the Osher Lifelong Learning. And he, you know, was talking and he said, oh, what you're doing is what I did when I was a kid. During World War II, when I was in Florida, you know, there was a big problem with mosquitoes. And the big kids, they got to work on the pineapple farms because all the dads and moms, well, all the dads were off working, you know, and fighting during the war. And so the big kids went on the pineapple farms and the little kids went around dumping water out. And so this was, you know, what we're doing is not new, but it's kind of things that we have kind of forgotten during the DDT era. When we controlled mosquitoes, we got out of these behaviors that are so important. And today we don't, we have a lot of issues associated with our mosquitoes, and they are now resistant to a lot of pesticides. And so it's even more important that we step up our personal behavior to protect ourselves from mosquitoes. So this is for you librarians out there that have heard of this particular writer. Does anybody recognize the art here? Go ahead and put it in the chat. And Vivian or Teresa, you can tell me if anybody recognizes this artist. But this is something from World War II. This was done in 1943. It's called This is Anne, She Drinks Blood. And Anne stands for Anopheles. This is a mosquito that causes malaria. And a very famous children's writer, before he was teaching people how to read, kids how to read, was helping service people around the country protect themselves from malaria. And this is part of that PR campaign. Next one. So what he did was, in these public health announcements, is he would say, it's up to you. You will be given sleeping nets, use them, because we know that Anne, the Anopheles malaria mosquito, is most active at night. She'll bite you at night. So don't go swimming at night. Don't sleep without a bed net. And make sure you keep your bed nets, you know, carefully curated, get rid of the holes. So this was the message from the US Army, and it was very, very successful. But malaria is a huge problem internationally. It is responsible for most of the mosquito-borne disease fatalities. There are literally like 300,000 cases a year of mosquito-borne disease. Most of those are malaria. We want to identify that malaria mosquito. And so now I'm diverging a little bit about what you can do in your neighborhood, but tell you why it's so important and how you can connect your patrons to real important science that serves humanity, right? And that is, you can very easily identify the malaria mosquito under the microscope. So here's that little clip-on microscope that I told you about. Here's some mosquito larvae that were found in a container, and you just look at them and you go through the key, and what you'll see is down at the bottom, on the bottom picture here in the middle, you'll see that it's very easy to identify Anopheles. They are the only ones that don't have a breathing tube, and so you can use this and say whether or not you found it. This is the story now that is really important, and here I'm talking about a problem that we have in Southwest Asia and in Africa, and the critter is called Anopheles stevensi. It's a mosquito that was found originally in like Saudi Arabia. It has moved now to India, and we're now finding it in Africa. And we are using this habitat mapper by community entomologists and citizen scientists in Ethiopia to identify if whether or not they have this invasive vector. And I'm going to tell you why it's important. So I just want to show you, here's where this is these invasive hitchhiking mosquitoes going from here, Saudi, all the way to Ethiopia. And this is why this is a game changer for malaria. These guys are not like the usual mosquitoes for malaria, which are floodwater mosquitoes that like swampy habitats. They like irrigation ditches. These are container breeders. So if you get them in a city, there's lots and lots of places for them to be, you know, just standing water in containers and trash. But the big thing is these are day biters. So bed nets don't help. And if you have been following all the work done by Bill Gates and the work, the great successes we've had with controlling malaria around the world, it's related to distribution of bed nets. So this is why this is so scary, because this Anopheles mosquito that carries malaria doesn't care about bed nets because they're biting during the day. So we want to make sure we're trying as a international community to stop the spread of this mosquito. Okay, scientists harness the power of the volume and velocity of citizen science big data. And we're using this to the health challenge of vector-borne disease. So this was one of those mosquito challenges that Vivian was talking about. These are pictures taken by our citizen scientists, and we need thousands and thousands of photos of mosquitoes in the field, not in the lab, because it's different. This is a team of scientists that I have the pleasure of working with, and this is a artificial intelligence enabled citizen science surveillance for Stephensai. And this is the team. There's a bunch of scientists here from CDC and different universities, myself from IGES, and we have sponsorship from a number of organizations. Next one, please. Here's what we have found. And we are now working on publication for this. This is like new news, but here's why citizen science is so important. So back before we even were really working on this problem of Anopheles stephensai going to Africa, we had people using the mosquito habitat mapper. And I forgot to mention, but it's really important that you can use this app in all over the world. It's GLOBE countries, or 127 countries. The app is in 12 languages. It's extensible, so if you need a new language, we can put it in there. But anyway, here in Madagascar, we had a citizen scientist that found something that looked like an Anopheles mosquito, but Anopheles mosquitoes, as you know, we expect to find them in ditches, but they found them in a tire. So when we were going through all our data, we went, oh, this is wrong. This guy couldn't have found an Anopheles in a tire. So we went back to the voucher photos that the citizen science used, and sure enough, it's an Anopheles. So we are working now with this team developing AI, and they ran this mosquito through the new AI that's identifying the different species. And sure enough, it came up as Anopheles stephensai. So back in you never know when your data is going to be useful. This was done in 2020 by a citizen scientist, and it's become an incredibly important scientific find that is going to be published very soon. So I just want to give you that example because it's so profound that I thought it was worth running 1 minute over. Okay, so just want to say there are other mosquitoes that are found in Costa Rica, and in the Caribbean that are also spreading. This problem of hitchhiking mosquitoes are a problem everywhere. And here's what you have to do. Just go. You'll never see the landscape again. You'll begin to see, once you use mosquito habitat mapper, you're going to see habitats everywhere, like cut bamboo. And then what you'll find is when you do this, people love looking at these critters under the microscope. They're absolutely fascinating. And if you're working with youth, it's even more exciting. So these are some of the things that you can do in your programming. And this is the last slide. Safety first, please. Just remember when you do this project, please tell your patrons that, even though most mosquito bites are harmless, some can be dangerous. So be sure to cover up your body, use a protective insecticide or pesticide, and I think you'll have a really, really interesting time. Okay, Teresa.
Thank you, Rusty. Next slide, Vivian. And I think what Rusty said about seeing your world through different eyes is so true with citizen science. And so I wanted to talk a little bit about how you can get the data. If you go to the next slide, all GLOBE data is open access for everyone to use. And the data are being used by both research scientists, as Rusty just described, and for student research and for all communities to use. So if you go to observer.globe.gov, there is a menu item for Get Data, where you can find several tools for discovering, for accessing, and for using GLOBE data. And these include things like an API programming interface for data calls, tutorials, a user guide, which includes all of the metadata, which will be important to librarians, and also tools for searching and downloading GLOBE data and visualizing the data on a map. And so the data can be downloaded in easily accessible format, CSV file format, and the photographs can be downloaded in JPEG format. And an important note is, while all of the data submitted is all available, no personal information for observers is accessible. There's also access to curated data sets for special observations and for data sets used in publications. So all of the peer-reviewed publications using GLOBE Observer data are listed on our publications page on observer.globe.gov. And these are also discoverable through indexes like pubmed.gov. And you can see on the screen a search for citizen science and mosquitoes. And you can see two of our latest articles using mosquito habitat map data, which are also free access for the full article. And I think some of the most powerful information that we can share are examples from our library and other partners who we profile on our website under the menu People. If you hadn't caught on, if you go to observer.globe.gov, that's a perfect launching point to all of these resources that we described, and I put that link in the chat. And so Vivian Bird, our very own Vivian Bird, who we've worked with for the past 4 years, 4+ years, I think now, and we have a link in the slides, I'll put it in the chat, where Vivian described some of their programs and resources, a presentation that she did for libraries and citizen science. Another library partner that we work with is LaSalle Public Library. And while Los Angeles Public Library is a very large library system, over 70 branch libraries, LaSalle is a single building library that serves a rural community with high poverty. This profile of their programming librarian, Donna Blomquist, describes their program where they partnered with the nearby nature preserves to where they set mosquito larva traps to take the mosquito habitat mapper observations. They also do citizen scientist walks along the Illinois River and use that as an opportunity to clean up litter and to remove mosquito habitats in containers. So litter, something as small as a bottle cap, is enough water for a mom mosquito to lay her eggs and for mosquito larvae for her to breed. So I think another important message is you don't have to go somewhere far away to do science. It's right there where you are. Another library partner who we've worked with is the Pioneer Library System in Oklahoma. We have a link in our presentation to their presentation to one of our GLOBE Mission Mosquito webinars, where they talked about how they recruited volunteers and programs that they ran using the GLOBE Mosquito Habitat Mapper. In the middle photo shown there is the glass wall of the library computer lab, where they drew a mural showing the mosquito life cycle, and they posted information about participating in their citizen science project in taking mosquito observations for NASA. They use that computer lab to do on-demand training for the mosquito habitat mapper, and they also partnered with local university scientists. In the top right-hand photo, you can see Kaya Franca, who is a scientist at Southern Nazarene University right there in Oklahoma, who was interested in the data for his research, and he would also support library events showing how to do the observations. So it's another good example of making local connections. We have a number of resources to support your programs. These are things that can help build science content knowledge and to practice the kinds of things that citizen scientists will be doing to collect the data. For example, in that bottom left-hand corner are some printables that we have on our website. One is called Mosquito Habitats and Hideouts. It's a bingo style game to identify all the different habitats where you might find mosquitoes larvae. We have build a mosquito larva trap. These are activities that are very hands-on. They've been tested in libraries. We have a number of libraries that have used these materials in their programs. Another resource that I wanted to mention is the Zika Zine, which is a comic, a science-based comic. It's available in multiple languages, and that's online. We link to it from observer.globe.gov, and Mosquito Larva Hunters Activity Guide. All of these are also in our toolkit for informal educators, not just resources for doing the mosquito habitat mapper observations, but also for doing globe clouds, for doing land cover observations and trees. And so lots of hands-on activities, resources like book lists, videos, FAQs, frequently asked questions, things that can help to build that content knowledge and the skills to do the citizen science observations. Oh, and one thing I also mentioned is all of these resources have been used in programs for children, families, teens, adults, the whole spectrum of your patrons. And I hope some of you will join us on November 10th. We have a webinar series as part of our GLOBE Mission Mosquito campaign. And Dr. Rusty Lowe is going to be presenting on citizen science in Brazil. Rusty just got back from the second half of her Fulbright Scholar Award working in Brazil. And that webinar is going to be on November 10th at 2 p.m. Eastern Time. The webinars are all recorded, so if you can't make the live event, you can also register to get the link to the recorded webinar, and those are also linked to from our campaign website, and the link is there. Another thing that's really important is find those local partners who you can work with that can help support your program. And one type partner, GLOBE, is found in 127 countries. You can find out who the GLOBE country coordinators, GLOBE partners and schools and contacts are in your area. So if you go to the GLOBE community map, and the link is there, I think somebody's putting that in the chat, you can click on any of these icons. You can search for, search for GLOBE partners or GLOBE country coordinators. And I clicked on Taiwan because Vivian is in Taiwan right now, but then you can see who all the GLOBE schools and contacts are in your area. So I'd strongly encourage you, if you're interested in GLOBE, to find out who is in your area who's doing GLOBE. Another partner many of you may know or have used SciStarter. It's a portal for finding citizen science projects. But it's also, SciStarter has been very active in working with libraries, and they have a library and community guide to citizen science, which has lots of useful information on how you might find local partners and how you might incorporate citizen science in your library, in your programming. They also have developed citizen science kits that they've tested with libraries, and these kits, like Vivian had described, include everything you need to do the project, but also some additional materials to really enhance the experience of citizen scientists. And one of their newest kits is mapping mosquito habitats that they collaborated with our team on. That's for doing the mosquito habitat mapper. Another thing that SciStarter does, they have SciStarter Live Facebook webinar events. It's on Zoom, or you can watch on Facebook, where it's on Tuesdays at 2 Eastern Time. They're also recorded. Each week they demonstrate a citizen science project and how to do that project. A couple of weeks ago, we did a Globe Observer Trees SciStarter Live. We're right in the middle of a Globe Trees Challenge where we'd like to get as many observations of tree height, which you can do using your mobile device. So we use these challenges as a way to recruit new volunteers and to get a lot of observations over a short period of time. So that challenge goes through November 11th. And as Vivian described, the BioBlitz that they do at Los Angeles Public Library, you can do your own local data challenge using any of the resources that we've talked about to engage your community and to collect data that's useful for your community. Some more partner resources. We worked with the Smithsonian Science Education Resource Center on a community resource guide called Mosquito, and this is available in a number of different languages. It's for middle school and up. It could be used, it's very flexible in its design. It can be used with for middle school to college students to adults in your community. So I would recommend checking that out. We also worked the National Institute for the Environment and Health created a series of climate change and human health lesson plans, and they incorporated the mosquito habitat mapper into that set of lesson plans. And of course, Vivian, I had to note your neighborhood science toolkit, which is a wonderful resource showing how you partner with and giving lots of advice on creating a neighborhood science program. And I just want to circle back to the really important points that Vivian made at the beginning about the UN Sustainable Development Goals. And this image is from a really highly recommended by me article in Nature Sustainability called Citizen Science and the United Nations Sustainable Development Goals. And it shows in Black text at the top those traditional sources for measuring progress toward the UN SDGs, but also at the bottom in blue are things that may not be, they're non-traditional, things like Earth observations from space, commercial data, and citizen science data. So it's a really good article talking about citizen science data in the context of the UN SDGs. So some things to also to think about: citizen science volunteers and the SDGs, they model the kinds of behaviors and attitudes needed for contributing to these goals locally. They provide a way to mobilize people and give a sense of opportunity and ownership regarding these local challenges. These sustainable development goals are these very broad, very noble ideas like good health for all. But doing something like citizen science gives you something very concrete and very practical that you can do. In the case of the mosquito habitat mapper, looking for places where water collects and mosquitoes can breed and removing those. A very simple action helps to make your community safer. And so all of this information is in that article that I would highly recommend. I just wanted to acknowledge our NASA sponsors. We are a NASA partner, and we also acknowledge the contribution of all of our citizen scientists and our library and community partners. I think, Vivian, I'll hand it back off to you.
I just want to end our presentation with a few testimonials from the participants of our neighborhood science programs. They are the reason that LA Public Library continues to advocate for citizen and neighborhood science in the libraries. As we all know, one of the key building blocks of a sustainable community is active and informed citizenry, because we cannot solve what we don't understand. And believe it or not, even in the most developed countries, there are still people who don't really understand the sustainability issues and environmental challenges facing our planet or our communities. Libraries of all types are vital to the achievement of the Sustainable Development Goals. We're not only the institutions trusted by the communities we serve, but we also have the ability and responsibility to enabling the public to learn about these pressing sustainability issues, especially in the neighborhoods where information is not really available or accessible. Most importantly, we can empower and motivate people who are impacted by these issues to take actions to make their neighborhoods and the world a better place for everyone's health and well-being. And that's not just for humans. I'm talking also about wildlife and plants. So that's my last word for the presentation. Thank you so much. And I'm going to hand this back to Beth.
Well, as we wrap up today, I just want to say how amazing this was. I learned so much, and there are so many resources. So I really hope people that are listening in will go seek out some of those resources. And thank you all so much for your time. I don't see anything in the Q&A, and since we're a little over the hour, maybe we should just end for now. But if you're interested in learning more about ENSULIB, I'm putting the little YouTube video in there. You can learn more about our group. And please go out and seek out these resources that they shared today and become a citizen scientist in your own neighborhoods. Thank you all.
Thank you, everyone.